am Sadaranga from the University of Sri Lanka, and my research work is on fabrication and elevation of Sri Lankan graphite-based rechargeable battery. If I move to the outline, here I would like to brief my presentation into introduction, experimental part, research discussion, conclusion, and references. So, if I move to introduction, what are the rechargeable batteries? Simply it is a energy storage devices. So as you know, it converts the electrical energy to chemical energy and store, and then when you want it back, the electric is charged and it gives a electrical energy. As that way, rechargeable cells plays a major role in gateway requirements, such as mobile phones, laptop computers, electrical and hybrid vehicles, and restaurants also. So, in the context of rechargeable batteries, lithium hydride and nickel hydride technologies are very famous because they have higher energy density, effective discharging rate, and faster charge-discharge behavior. But the contradiction occurs here is that they are very expensive and very unsafe and have a bad impact to the environment. So, this poses the requirement of fabricating a low-cost, altruistic, environment-friendly rechargeable cell. So, in this respect, several strategies have been identified, such as replacing hazard material like lithium and employing non-liquid based electrolyte and using low-cost materials. In my study, my attempt was to fabricate by going those strategies. My attempt was to fabricate the battery using zinc as anode, gel polymer electrolyte as the electrolyte, and then graphite as the cathode. So, if I move to the experimental part, as I said before, cathode come up with the graphite. Actually, it binded with the PVDF as the polymer. It was fabricated using 85% to 15% of ratio, and using some acetone. The slurry, homogeneous slurry was fabricated and deposited on the stainless steel. This is the picture shows the real image of the cathode. And the electrolyte, as I said, my electrolyte was made up with gel polymer one. Initially, gel polymer electrolyte have three components: polymer, salt, and solvent. So I chose polyethylene chloride as the polymer, and the salt for the ion transfer I use zinc sulfate, zinc trichromethane sulfonate, and for the solvent I use ethylene carbonate and propylene carbonate. The right order of these components were Maxwell tested and seated for 137 Celsius for 30 minutes using hot press method with bubble free homogeneous viscous film. The image is the electrolyte. Now the fabrication. Picture shows the cross-sectional image of the fabricated battery. So GPS, gel polymer electrolyte is emitted by two zinc anode and graphite cathode. The below image shows the real battery. So if I go for the performance evaluation of the battery, first I measure the open circuit voltage, then the cyclic wattmeter test, the allosteric charge discharge test, and the electrical impedance spectroscopy. So CV test, I use 0.1 to 0.1.6 volts as the potential range as to get the anodic and cathodic peaks, and for the DCD test, I use the potential range of 0.1 to 1.4 volts, and the maximum charge discharging current was 120 microamperes. And for the EIS test, I used the frequency range of 400 kHz to 10 kHz. So, discussion. This is for open circuit voltage. I get around dose of open circuit voltage around 1.00 volts. So, cyclic voltmeter test. Here we can see two dominant peaks. So, we can suggest those as anodic and cathodic. And other than those, we have smooth line of behavior of the cyclic voltmeter. And if I go for some detail for the CV test, cathode peak occurs at 1.09, that is a breaking of zinc. And same at anode peak came 1.18 volt, that was stripping. So reduction and trading and reaction and oxidation come with very near potential. That shows the reversibility of the electronic cell is very good. And we have no other peaks, so that means that cell is stable. This is charge discharge test. So we can see here, this is our initial charge discharge profile. Symmetric charging and discharging behavior can be seen. This is the discharging capacity for the cycling number. I use more than 105,000 cycles, but we have rather linear capacitive behavior. So I go to the detail. So we see the symmetric discharging profile, that proves the absence of unwanted reactions. And initial discharge capacity was about 13 milliampere hours per gram. And after 105,000 cycles, it took 11 milliampere hours per gram. This is slow reduction. This may be a material installation and preservation players are fabricate taking beyond the two interfaces. And also we do have a negligible IR drop, that is internal resistance of the cell is very low. So for the EI test, actually this is the typical behavior for the EIS electroscope for the battery. So in here, the first intercept is represent for the bulk resistance of 4 ohm, and for the diameter of the semicircle shows the charge transfer. That was about 720 ohms, and then this spike there also. So actually spike shows the diffusion and capacitive behavior. The tilt here is because of the uneven surface micron the cathode, carbon cathode. For the conclusion, I would say the battery of the configuration, zinc anode and carbon graphite phase cathode, amidst the polymer light was successfully fabricated, and I get the open circuit voltage of 1.03 volt, and the capacitive behavior was very slow by the continuous cycling. And the results obtained from the CV test and the cycling test and EIS test prove that the cell is stable, and I suggest this can be used for low power requirements with the benefits of low cost and safety. These are my references. So I here gratefully acknowledge National Science Foundation, National Research Council and the WADSS of Sri Lanka who gave me the financial assistance and the rotary facilities. And also I would acknowledge the Global Graphite and the PSC for giving us the PO grade standard graphite samples. Thank you.
Subject is open for discussion. I will again start. Now using open circuit voltage 1.03 volts. Now I don't know what particular battery, but if you take a lead acid battery, the open circuit voltage could vary from less than 12 volts to 13.6 volts. immediately after charging, before disconnecting, probably will be something like 13.64, and immediately after disconnecting, the open circuit voltage, would be something like 12.8, and depending on the state of discharge, the open circuit voltage is a variable. So when you say 1.03, at what stage of charging is that open
The very
circuit voltage?
moment after it is fabricated. Open circuit.
Yeah. Is that a fully charged battery or a half charged battery, or what is the state of charge?
The open circuit voltage showing its full capacity, full voltage it can be.
Okay. So
Then
that is full charge.
I mean, so there is full charge, no, charging. The very potential he can go. The battery can go high. That's the open circuit voltage. But it may differ when the preservation layers are burning between the zinc and the electrolyte. But as a manner, when we fabricating a battery, everyone asks what is OCV. So if we get the magnesium battery, it may 1.6. But when it's charging 400 and more than 1000, it may get 1.504. But the OCV is the very first after fabricating the battery. OCV gets.
Yeah, but you are looking from the chemical point of view, I am looking from the electrical point of view. So I am looking at the output, you are looking at the input. That is fine. But you should say what is, because in your case, you would know what you mean by open circuit voltage. For us, it also depends on stuff. Because when you check the life of a battery, you are quite often looking at the open circuit voltage. How much has it changed?
You specify a number of performance figures like the capacity failure. So I understand future, now this is initial research and then future enhancement will be there. But now at the present state, when you compare these performance figures with the available, the other basically battery models or cell models, how do you position your
So this is first time. With carbon is also employing for cathode, but carbon with the electrolyte as a gel polymer with the carbon is first time. So main thing is to synchronize these anode, cathode and electrolyte. They should be synchronized. I have done this, getting 103 volt, and here I get 1,000, more than 1,500 cycling. Here. So here charging discharging is good. So we jump the very one gap. So improving the energy density, power density is also next step. So I have, even here I get 30 milliamp is very low compared to lithium ion. They have 800, even 2,600 also. So it is up to us to change the morphologies and other things, binding some.
So let's take one example, the capacity failure. So how do you compare your
So this is very good. Even the lithium ion battery, just we told mobile phones, it contains only 1,000 charge discharge. I think they did get that crystallinity of the lithium three-dimensional mesh. It getting solved. That is why the battery is getting solved. But here, no, because polymer is there. There is no that sort of.
Unfortunately, the time is up.
Okay.
So let us show our appreciation.
Thank you.